everybody, this is Mrs. Heist, and I'm here to talk about our macromolecule lab. So if we go into this week's folder, open up Wednesday, we have our lab modeling macromolecules. In this lab, you're going to need two things. So we've got a website here that you need to have open and available, and then our modeling macromolecule lab. You'll need to make a copy first in order to edit. So I'm going to open up both things. Here's my lab. File. And I want to make a copy so that I can edit this. And now I need to come and open up the website I need to use. So this opens up. You can just close this. It's giving you some terms of use and asking for a donation because this is an open source platform. But we'll go ahead and close it for now. And usually some random molecule is here to begin with. Let's go take a look at our lab though. We're going to use this to help us model some molecules. Part one, you're going to look at different organic and inorganic molecules. We're going to have to write in the empirical formula and then show the structural formula. So our first one is water, and we'll use this to practice. I'll just come search for water, and here it is. And we can see we've got a little 3D molecule here. And then this right here is our structural formula. So I'm going to take a screenshot of that. And I can paste it here. And then I'm going to edit because I don't need everybody seeing my entire screen. Empirical formula, if you remember from chemistry, was going to be the letter abbreviations. In this case, water is H2O. So you'll need to go through and find pictures of carbon dioxide, the oxygen gas, and ammonia using Molbium. On to part two is looking at the molecules for cell energy and structure. So first it gives you several monomers to look at, or monosaccharides. Let's take a look at galactose together. So I'll come over to Molvio. And let's pick pure galactose. And so here's my image. This is a really busy image. If you don't like seeing all the C's and H's, you can also use this view as well. And again, here is our 3D structure. Our carbons are the gray balls. We've got the hydrogens are white and oxygen is red. So I want to take my picture. Come over here and I want to crop all that. Crop all that out. There we go. So I can just see this. Now for my empirical formula, I know there's carbon, hydrogen, and oxygen, but now I need to count. So if I come over here and I can count this using a few different views, I can either put up my letters or I can look at this molecule here. And carbons, I've got 1, 2, 3, 4, 5, 6 carbons. So 6. Hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And for oxygen, that's the reds. 1, 2, 3, 4, 5, 6 oxygens. So there's my empirical formula for galactose. And to be properly correct, and I'm sure your chemistry teachers reinforces a lot, those should all be, all the numbers should be subscripts. There we go. Now moving on to the lipids, looking at a couple of fatty acids. For our saturated fatty acid, we're going to search, it tells us in the instructions here, fatty acid C10. That means that there are 10 carbons. So fatty acid C10 is the one that I want us to take a look at. And hello.
Just dropping this off.
And so here we have our fatty acid. We can see we've got our carboxyl group over here and our long chain of carbons. So I'm going to take my picture. And then I can paste it here for my saturated fatty acid. So we know this is C10. Need to count how many hydrogens and oxygens are. So there are 2 oxygens, that's easy. Whoops, where'd I go? 2 oxygens. For hydrogens, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Things. For the saturated fatty acid, we're actually going to make one of those. And we are going to do that by deleting a hydrogen from 2 neighboring molecules. And then we're going to change one of these bonds to a double bond. And then here it is. We're going to click this 2D to 3D. It's going to adjust our molecule, and we can see here in our 3D molecule we now have a bend. And this is what I will use for my picture. For my empirical formula, we're still C10. We're now H18 and O2. All right. On your own, we've practiced using MolView. You're going to go through some triglycerides, look at the difference with those. You're going to look at some amino acids. You're going to make a tripeptide, and then take a look at our nucleic acid monomers, or not monomers, excuse me, building blocks, guanine, cytosine, adenine, uracil, and thymine, as well as the sugars, the deoxyribose and ribose. Once you have your lab completed, there are a series of analysis questions to answer. As always, email your teacher if you have any questions.